In this example, we will solve for all exact solutions to the equation tangent of x is equal to 1/4 in the interval 0 to 2 pi. Then we will find all solutions. So if I want to try to evaluate this to get x by itself, and I have tangent of x, that means I should take that expression, tangent of x, which equals 1/4, and I should apply the inverse tangent function to both sides. Arctan and arctan, which gives me arctangent of x is equal to arctangent of 1/4. Or if I simplify there, just x equals arctangent of 1/4. Now this ratio of 1/4 is not a ratio I'm familiar with from the unit circle, so I will simply leave it as it is, just keep it as arctangent of 1/4. However, I do need to know what this means and where this angle measure is. Keep in mind that arctangent of 1/4 is defined based on the range of arctangent to be within negative pi halves and pi halves. More specifically, because that ratio of 1/4 is positive, this angle measure is going to end up being between 0 and pi halves, or some angle measure in quadrant 1 of the unit circle. What angle measure exactly? I don't know unless I want to approximate using a calculator, but I'm going to keep it as it is. So arctangent of 1/4 is an angle measure in quadrant 1. However, that's not the final answer, because our original question of where does tangent equal a ratio of 1/4 should not only happen in quadrant 1, but should also happen in another quadrant where tangent is also positive, that being in quadrant 3. If I think about a picture of this, we have one answer up here in quadrant 1. That is our arctan of 1/4 answer. But we should have another answer in quadrant 3 that shares the same reference angle, which means the same distance from the x-axis, which should also be arctangent of 1/4. If I want to find what that angle measure down in quadrant 3 is, what I could do is take pi and then add arctangent of 1/4. So arctangent of 1/4 is one solution between 0 and 2 pi, but another one would be arctangent of 1/4 plus pi. That would also be in quadrant 3, and therefore between 0 and 2 pi. We have now found our two singular answers between 0 and 2 pi. We are then also tasked to find all solutions that work. So what that means is, well, arctangent of 1/4 is one correct answer in quadrant 1, but we could consider any coterminal angle measure to that as well, which means typically add 2 pi k. So I could say x could equal arctangent of 1/4 plus 2 pi k, where k is an integer, and also arctangent of 1/4 plus pi plus 2 pi k, again where k is an integer. And this would be fine. This is a full infinite solution set that demonstrates all answers. I found the two between 0 and 2 pi, and then considered any coterminal version of those. However, there's an easier way of writing this expression. And if you look at our drawing from before, we may be able to discover this. Our first answer was in quadrant 1, arctangent of 1/4. The way that we went from that to get to our second solution in quadrant 3 is that we took arctangent of 1/4 and we added pi to that. Well, think about what you would need to do to get back to your answer in quadrant 1 after that. Once we're in quadrant 3, if I want to get back into quadrant 1, I would add pi again. Once I'm in quadrant 1 to get back into quadrant 3, I could add pi again. Meaning there is a consistent way to go from one solution to the next solution instead of defining these two separate solution sets. I can combine these. And the way I can combine these is by writing it as just one line, that x equals arctangent of 1/4. And instead of adding 2 pi k to get the coterminal ones there, if I also want the angle measures in quadrant 3, I could instead just add pi k. Again, where k is an integer. What this would do is it would find the solution in quadrant 1, which is arctangent of 1/4, and then consider any other angle measures that are determined by adding pi times any integer. If you take that answer in quadrant 1 and add pi 1 time, that gets you quadrant 3. If you add pi 2 times, that gets you back into quadrant 1. If you add pi 3 times, that gets you back into quadrant 3 at a coterminal angle measure, and so on and so forth. Same would also apply if we subtracted some amount of pi. So that is the way that I can write the infinite solution set in just a single line for arctangent.